Welcome to The Explainer. Today, we're digging into a language that's been a powerhouse behind our digital world for decades. So what is Java really?
I want to imagine for a second that you're a programmer back in the early days of computers. You spent all this time building an amazing program for one machine, but then you have to completely rewrite the whole thing from scratch to make it work on another. It was a total nightmare, super frustrating. So, the biggest question on everyone's mind was, what if there was a better way?
And that's exactly the problem Java set out to solve. See, the goal wasn't just to make yet another programming language. It was about making a revolutionary promise to developers everywhere.
And that big idea gets summed up in this one powerful acronym, WORA, Write Once, Run Anywhere. This concept, also known as platform independence, is the absolute soul of Java. The idea that you could write your code just one time and it would just work on a Windows PC, a Mac, a Linux server, even your phone, without changing a thing, that was, and I'm not exaggerating here, a total game changer.
But to pull off a promise that huge, Java needed a really smart way to organize code. And the answer came from a philosophy called object-oriented programming, which completely changes how you think about building software.
You know, in the real world, we already think in objects, right? A car is an object. It has data, like its color or its current speed, and it has functions, things it can do, like start the engine or hit the brakes. Well, object-oriented programming just takes that same exact logic and applies it to code. It makes everything much more intuitive, especially when you're building really big, complicated apps.
Think of it like this. A class is the architect's blueprint for a house. It defines everything, how many rooms, the size of the windows, but it's not an actual house, right? It's just the plan. An object is the real house you actually build from that blueprint. And the cool part is, you can use that one blueprint to build a whole neighborhood of identical houses. It's the exact same idea in Java. You have one class, and you can create tons of objects from it. And this way of thinking opens up a whole toolbox of other cool ideas. You get concepts like encapsulation, which is kind of like bundling all of an object's data and its functions together in a secure little package. And then there's inheritance, which lets you build a new class based on one that already exists. It's all about keeping your code neat, tidy, and reusable.
Okay, so we've got the run anywhere promise and this object-oriented way of thinking. But what's the actual tech that makes it all work? What's the magic behind the curtain? What's Java's real secret sauce?
So, to get what makes Java so special, you gotta first understand the two traditional ways computers run code. First, you have a compiler. A compiler is like a translator who takes an entire book and translates the whole thing into another language before you ever get to read it. Then you have an interpreter. That's more like a live translator at a conference, translating each sentence one by one as it's spoken. Both ways have their pros and cons.
So, which one did Java pick? Well, here's the brilliant part. They didn't. They created this amazing hybrid system that gives you the best of both worlds. Okay, so here's how it all fits together. First, a programmer writes their Java code. Then, the Java compiler gets to work. But, and this is the crucial part, instead of making code for a specific machine, like Windows or Mac, it creates this intermediate universal thing called bytecode. This bytecode doesn't belong to any one platform. And that's the key to the whole system.
And this is the final piece of the puzzle, the Java Virtual Machine, or JVM. Remember that live interpreter we talked about? Well, that's basically what the JVM is. It's a custom-built piece of software for every single device. So there's a JVM for Windows, a JVM for Mac, a JVM for your Android phone, and each of them knows how to take that same universal bytecode and translate it on the spot for the local machine it's running on. And that right there is how Java pulls off write once, run anywhere.
All right, so that's the high-level genius of it all. But let's zoom in for just a second and look at the actual nuts and bolts a programmer uses day to day.
Before you can do anything in your code, you have to tell the computer what kind of information you're dealing with. Are we talking about numbers, or maybe some text, or just a simple yes or no? Think of these as your basic building materials.
Now don't worry about memorizing this whole chart. The big takeaway here is that these are just the most basic types. They exist simply to tell the computer if you're working with, say, a whole number, a number with a decimal, or just a plain old true or false. It's all about being specific so the computer knows what to do.
Okay, so you've got your materials, your data. Now you need tools to actually do stuff with them, right? In the world of programming, we call these tools operators.
The most common ones are the tools you learned back in grade school math class. We're talking about your basic plus, minus, multiply, and divide signs. They just let you do calculations with your data. Simple as that.
But this is where it gets really powerful. These operators let your program ask questions. Is this number bigger than that one? Are these two pieces of text equal? This lets your code make decisions and go down different paths depending on the situation. And this is literally the foundation of all logic in every piece of software you've ever used. So, after all this time, with all these flashy new languages popping up every year, why on earth is Java still such a huge deal? Why is it one of the most important programming languages in the world?
Well, it really just comes down to these three unshakable strengths. First, that platform independence, write once, run anywhere, is still incredibly valuable today. Second, its object-oriented structure is just perfect for building the huge, complex applications that run our world. And finally, that whole JVM ecosystem, it's like a super secure, stable fortress for applications, and big companies absolutely love that for their most important systems.
When you really step back and look at it, Java wasn't just another language. It completely changed how we think about writing software. It powers so much of our digital lives, from the servers that run websites to pretty much every Android app on your phone. It set a standard for portability that still inspires new languages today. Which makes you wonder, doesn't it? What's the next big idea going to look like?